Hello, and thank you for waking up this early. So my talk is called Python, Blockchain, and Byte-Size Blockchain and Byte-Size Change. The pain point that this talk solves is I became interested in blockchain, but it took me a lot of time to take separate pieces of information together so I'm able to understand what exactly is a blockchain and how can I, as a developer, make blockchain applications. So keep that in mind while I go through the presentation. Who am I? My name is Portia Burton. I am a full stack developer at The Atlantic magazine. So I do not work with blockchains at my day job yet. I became interested in blockchains earlier this year, and I am not a cryptographic expert by any stretch of the imagination. So let's begin. I used blockchain several times in this conversation. What is a blockchain? The best way to describe a blockchain is like a cross between a decentralized data store and BitTorrent. It's like a data store that is peer-to-peer. What is Bitcoin? Bitcoin is a type of cryptocurrency. The creation was based on a paper by Satoshi Nakamoto titled Bitcoin Peer-to-Peer Electronic Cash System. Peer-to-peer means that you are sending information or money directly to a person. For instance, if I am in China and I need to send money to my grandmother, I do not have to go through Western Union. True story. So Bitcoin is not the only game in town. There are many different types of cryptocurrency. So you can go to a cryptocurrency exchange, and this is what you will see. There are actually hundreds of different types of cryptocurrencies because they're actually not that hard to make. Bitcoin has the most valuation. There's also Athyrium. We're going to talk a lot about Athyrium. And then there are the others. Like I said, there are hundreds of different types of cryptocurrencies. Bitcoin and blockchain are often conflated. So what's the difference between the two? Bitcoin has a blockchain. It is part of a blockchain. A blockchain is a digital ledger of transactions, that decentralized data store peer-to-peer. Each transaction is cryptographically signed, and blockchains are trustless. This means practically you do not have to depend on a third party like a government or a bank when you're making transactions. Ethereum. Ethereum, I would say, is probably the next generation of blockchains. The first generation, I would say, was Bitcoin. Ethereum's different, and it has more features. This is the latest release of Athyrium. So introduction to Ethereum. Ethereum is a programmable blockchain, unlike Bitcoin. And every blockchain spawned from Ethereum has the same properties as the original Ethereum blockchain. Ethereum Virtual Machine is the low-level machine language of blockchain, but most people use a client. It is Turing complete, which is huge. Unlike Bitcoin, it has looping capabilities. You can actually interact with Ethereum with a real programming language. And it is also aware of multiple states, unlike Bitcoin, which is spent and unspent. So these are the advances of an Ethereum blockchain. And that's why in this presentation, we'll mostly be talking about Ethereum. So there are different, under the hood, there are different consensus mechanisms. This is how your blockchains work. Your first one is proof of work. So whenever you hear someone say that they're mining for Bitcoins or they're mining, this is the algorithm they're using is proof of work. And proof of work, there are several different algorithms. For Ethereum, it uses the Etosh-Dag algorithm. I don't know if it's Dag or Dag. And it is different than Bitcoin's Dagger Hashimoto algorithm. They're proof of work, but they're different algorithms that do a similar thing. The second consensus mechanism is proof of stake. The next version of Ethereum is going to switch from mining to proof of stake. Proof of stake is another way of validating. It calculates the weight of the node being proportional to its computational resources. The reason why proof of stake is being worked on is because it's less resource intensive than proof of work. So there are different chains. So these are Ethereum chains, what we're going to talk about. I like that picture. So these are the three main blockchains: public blockchain, testnet blockchain, and private blockchain. Public blockchain is a blockchain that is open to all. Everyone can read and interact with it. When we're talking about the testnet blockchain, I would consider it as more as the dev version of a blockchain. So if you are creating a blockchain or if you're creating a contract on a blockchain, we'll talk about that more later, you can use testnet blockchain and not lose money. Because when you're using something like a public blockchain, you are paying for the ability to compile contracts. I'll talk about that more later. And finally, there's the private blockchain. The private blockchain is probably the blockchain that industries are the most interested in because they have the most control over it. This blockchain is a blockchain you can create yourself. It can be freely accessed by others, or it can be invite only. In this presentation, we are going to interact with a private blockchain that I created. And our leading question: can an average developer build blockchain applications? Indeed, we can. Oh. But first, some more background. So I alluded to smart contracts. So what exactly are smart contracts? Smart contracts are also called dApps. These terms are used interchangeably. They mean the same thing. So smart contracts are stored on the blockchain and they're executed by code. The code is usually written in Solidity. Solidity is a special programming language for writing smart contracts. There's not only Solidity, there's also Serpent, but more people these days are using Solidity. Serpent, the syntax is very similar to Python. Smart contracts are powered by gas. What is this? So with Ethereum, Ethereum has its own cryptocurrency called Ether. Gas is a smaller denomination of Ether, and when you are compiling these contracts, when you're deploying these contracts, it is not free. You actually have to pay for the computational resources, and you pay not by using euros, not by using RMB or dollars, but by using gas. So this is an example of an interface of creating a smart contract. Gas is the name of the execution fee that senders use or pay. Value is if you want to send money from one person to another. So value is not the execution cost. Start gas represents the maximum number of computational steps. That's as much as you would want to pay. That's the maximum limit you would want to pay for executing a contract. And gas price represents the fee the sender is willing to pay for gas. So why are we here? Why do we care about smart contracts? Well, for several reasons. The implications of smart contracts is we can have self-executing legal contracts. What this means is there'll be less of a need for lawyers or courts because part of the legal system would be executed by these smart contracts that instead of using legalese, it would use code. Create American Idol where people can vote using generated tokens. Wait. The reason why I'm talking about American Idol, because I learned recently American Idol was how many people in the United States learned how to text. So, so American Idol, if you wanted to vote for your favorite performer, American Idol actually had these tutorials on how you can send a text. And who knows, maybe that can do the same for blockchain and smart contracts. Company boards can be ran virtually. So instead of having a chairperson, the chairperson will actually be the smart contract and it'll actually execute some of the proposals. Or if you have your own blockchain, you can have like a more secure Dropbox business model, where you will have a private blockchain and you'll be able to rent out space to other people, an encrypted storage space. And you can also predict financial futures based on Oracle. An oracle is like an external API, and like if you're betting on the weather, your oracle would be like the weather, and it will be connected to a blockchain. Demo time. Woo. Oh, people are clapping. I hope you clap by the end of the demo. Okay, so in this demo, we are going to interact with a private blockchain that I created. So there are different ways that you can interact with a blockchain. First is the terminal. We are going to use Jupyter Notebook. Oh, I hear yays. Good. Okay. So we're going to use the terminal. And this is there's a lot of information here, and I actually have some docs at the end of this presentation on what these different attributes mean. So there's G. G is actually the Go client. So if you're using Ethereum, the two clients people mostly use is Rust, which is parity, and Go. I'm calling this blockchain HackChain, and let's start it. The benefits of working on the terminal is that you're able to quickly get information about your blockchain. So if I want to know about the accounts of my blockchain, I can just use ETH accounts. And these are the 2 accounts on my blockchain. If I want to know how much money is on my primary blockchain, I can do that here. So let's set the index to 0, which is my primary blockchain. And let's see what the balance is. I am rich. I have over 24,000 Ether. All right, that's it. I'm leaving. And the best part about using testnet or your private net is that you can make money. So miners start. So this is the POW, proof of work algorithm. And you're not making Ether real Ether. You're actually making test Ether. So I am actually mining now. And if we wait long enough, we can see that I will be making money. Let's see. All right, give it a while. Yay! See, you see the pick? The pick shows that I've mined a block, which means that I am now making more Ether, which is pretty cool. That being said, this might be cool to me. This might be cool to some of you. But we can't expect all stakeholders to interact with the command line. So that being said, there is a GUI that is connected to this blockchain, and that is what we are also going to use. So the GUI is called Mist. And here is our main account. And here is our second account. Let's see. And this acts as a wallet, and this also acts as a way that you can execute contracts. So this shows us how much money we have. But if we wanted to create a smart contract, we would go to the contract section and select deploy new contract. From here, this is the area where we can create a contract. We are going to use Solidity in this presentation, and we are going to create a token to vote with. We're going to create a voting token. I don't have time to go over Solidity, so this is the actual code for the token. So we'll put it here. And to the right, if we have any mistakes with our code, it'll tell us, and it seems like it is running well. So let's pick a contract. The contract is called My Token. Now, what we're doing is not all that dissimilar to what Canada is doing. Canada, earlier this year, has made its own cryptocurrency. And if you wanted to make your own cryptocurrency, this is what you would do. So we'll call it my token. And initial supply, let's say 3,000. And what should we name our crypto currency? What should we name our token? Say it again. Oh, no. Let's go. All right, snake dollars. So we're going to name this snake dollars, and that's great. The decimal units will be 2. And since this is snake dollars, we're going to make the symbol SD. When we scroll down, scroll. So this is what I was talking about in terms of select fee. We actually have a choice on about how much we want to pay for the execution of our contract. The faster our contract is, the more that we have to pay. The faster it is to compile, the more gas that we're paying. So let's go for fastest because we're rich. We have like over 24,000 Ether. And deploy. Now when we deploy, it's going to ask us for a password, which I have here. We put in our password for our account and send transaction. Hopefully this won't fail. Thank you. Confirming. So what else we can do? Let's go to wallets. And getting back to our digital ledger, we'll scroll down. And this is our digital ledger. So as we can see, our new currency is being created October 2nd. Oh, I think it's ready. So, congratulations, we have snake dollars. Total supply, 3,000, and we can use this as a cryptocurrency, and we can also use this as a token. So cryptocurrency, so when we're making tokens, it can be used monetarily, or it can be used as like a ballot. So there, we went through a blockchain, we interacted with a blockchain, and we also compiled a smart contract, so cool. Moving on. All right, demo time's over, sorry. But what about Python? What about it? I was supposed to say, there is the Python Athyrium client. I personally don't use the Python Athyrium client because A, I had dependency issues, and two, it's actually not the fastest. If you want to go for speed, 3 months ago, I would say use the Go client, but Rust has a new client, which is called Parity, and Parity is actually faster than Go. That's something that I will be using after this presentation, is Parity. But if you're interested, there's regular commits. You can commit to the Python Ethereum client. All right. Other ways that a Python developer can interact with the blockchain. One is check out BigChainDB, contribute to Open the Bazaar, get Web3 to interact with Django or Flask. I think number 3 is really exciting, but let's start with number 1. BigChainDB. So the hope of BigChainDB is to take the features of a traditional database and a blockchain and create a blockchain where you can actually build applications. BigChainDB is exciting because one of the services that I use, Ascribe.io, it's a marketplace for creators, actually uses BigChainDB. I like BigChainDB because the problem with like blockchain technology is that a lot of it is not in production yet for other projects. Like if you look at Slockit and if you look at other blockchain projects, they'll say it's in beta. Like there's very few projects that I've seen that's actually being used in production outside of Bitcoin. It's a hybrid of a database and blockchain. It's NoSQL data store. So this is a comparison. We won't go over that. Web3.js. Web3.js is a way that you can have an application connect to the blockchain. The only framework I've seen that uses Web3.js is Meteor, but theoretically, if you're using Django or Flask and you want to be able to interact with a blockchain, this is the way that you can go about it. And you can interact to a private blockchain or like the public blockchain using Web3.js. Why should we care? Why should we care about blockchain? Why should we care about cryptocurrency? Democracy and governance. But in this case, Obama, there's more spectating and hopefully less sport if we're using a blockchain. Democracy as we know it can potentially change, which means that voting can occur on the blockchain and we'll be able to verify a person's vote by looking at their hash. Agreements can be controlled by code as opposed to legal contracts, so there'll be less need for legalese and a less need for courts. Note I say less need and not eliminate. This is an alternative way of keeping track of identity. This is really important if you are a refugee, if you are not part of a country and you want to have an immutable identification that can be used everywhere, a blockchain would be able to address this problem. Laws and bills can be kept on a blockchain and create a permanent record which cannot be changed. Financial industry. The financial industry is actually already taking advantage of the blockchain. More transparency, more control. You can transfer money using a blockchain and not Western Union or a bank or a government. Transparent immutable ledger, which means that you cannot change the ledger, that transactions are permanently on this blockchain. And the more exciting one, I think, is number 3, is access to capital for nations that lack a dependable banking system. We take for granted in the United States, there are many flaws with our banking system, but there is a system that we can mostly rely on, not including Wells Fargo. And there are places where there are great ideas where people want to build companies, but they don't have access to a loan system. They don't have access to capital. With a blockchain, you'll be able to have access to money even though you might be in a country that does not have a dependable banking system. This is also good for perhaps the unbanked. If you don't want to go to check cashing, if you don't have access to banks, you can perhaps use a blockchain. So this solution could also be used in the United States. Less sharing in the sharing economy. Peer-to-peer profits, which means this is the ability to rent out rooms and rides without giving a portion of the profits to a third-party company. With third-party company, I'm talking about, I don't like to name names, but like Airbnb and Uber. In this case, a person can find you and you can keep 100% of the profits because they'll find you on the blockchain. Musicians can earn more money when listeners stream their music. This is already happening for Ascribe.io. So if you have a music, your fans can listen to your music and 100% of that money will go to you and not like Spotify. It will be an alternative marketplace for creators such as Ascribe.io and OpenBazaar. I haven't worked with OpenBazaar, unfortunately, which I plan on doing this week. But I actually do have something on Ascribe.io, and it's great. Like, my creation has a hash, and a great part about Ascribe.io is they're really enthusiastic about people using their platform. So if you're using Ascribe.io, then they would be very happy, and you get a lot of support. I'm sorry, it's not all milk and honey in the land of smart contracts. So smart contracts have a lot of issues right now in October 2016. I'm not an expert, but these are some of the bugs that are associated with smart or Solidity contracts. There's the transaction order bug. This is the bug that influenced an Ethereum contract back in June. If you're keeping up with Ethereum, there are two different types of cryptocurrency for Ethereum. There's Athyrium and Ethereum Classic. That is because an account was hacked into, and Ethereum decided to do a hard fork. And this hard fork, they created a new currency, but people still use the old currency, so you have Ethereum and Ethereum Classic. And that is because, partially because of this bug. There's the timestamp dependency bug. The time on a blockchain is not the same as Unix time. And then there's the unchecked send bug. These are the three most common bugs. But however, if you want to know more about bugs, there's a it is a presentation on smart contract bloopers. So the head engineer of security of Ethereum, he created a presentation of all the different ways that your contracts can go wrong. And I think he actually uses real examples of contracts that are in the wild. All right, enough about me and more about you. So let's say that you're into this blockchain thing and smart contracts. How can you get started? Well, here's a list of how you can learn what Solidity is, how you can create your own smart contract and your own blockchain. And finally, and this is how you can contribute to existing blockchain projects. Both of these projects are Python, and I would have to say that Python does have some mature blockchain projects where you can just like step in and start contributing. If you want more information about me, here, name, Twitter handle, and this is where you can find the slides. And finally, thank you.